Today, so our agenda is to talk about exercises on antiderivative of a function. Then after that, general power formula for integration. And the next one, after having exercises on the following topics, we're going to have discussion on integration involving logarithmic functions. So this is the logarithmic formula for integration, which is the second formula, basic integration formula. Logarithmic formula for integration. So this is to remind you that integral calculus requirement, differential calculus, okay? In particular, differentiation. So you must be familiar on the different differentiation formulas, specifically finding differentials, okay? But of course, to find differentials, you need to know how to differentiate. So applying the different formulas for finding derivatives of functions, algebraic transcendentals. When you say transcendentals, these are what? These are trigonometric functions, inverse trigonometric functions, logarithmic, exponential, hyperbolic, and inverse hyperbolic functions. Is that clear, guys?
Yes, sir.
Okay, so let's begin with exercises. No? So we have exercises.
Oo. Next pa kami next siya.
Saka ati kami, wala sa nasabi lang. Hindi man.
Hindi nalabot siya.
Ay, merong nagda-dialogue. I'm
Oo,
hearing.
namagagamit na siya. Hindi labot. Hindi labot.
Please check your background, guys.
I mean, my extension code.
Could you please check your background? So I am hearing things, guys. Okay now, thank you. So we begin with antiderivative exercises. So letter A, we have antiderivative. Okay, antiderivative of a function. Oh, can you recall what an antiderivative of a function is, guys? Huh? Anyone? What is an antiderivative? Or when do we say that a function is an antiderivative of another function? Guys? Anyone? Guys? So when you say antiderivative, so a function f, let's call denoted by capital F, is an antiderivative of another function denoted by small f on an interval, let's say I, if the derivative of capital F with respect to x is equal to small f of x for every x that you can find in the interval I. So that's what we mean by antiderivative. Okay? So in other words, given the derivative, we're looking for, or in particular differential, we're looking for a function whose derivative is the given. So in your differential calculus, you were given functions and then you were asked to find what? To find the derivatives, either derivatives or differentials. This time, we are given derivatives and we will be looking for what? For the functions. Kaya it's like given on hinahanap ngayon. Given ngayon, hinahanap nyo noon. Okay? So that's what we mean by antiderivative of a function. So again, let us have the following exercises on antiderivative. So let's say we're given the following. By guessing, determine the antiderivative. Okay? So And then we're going to have also exercises on identifying parts of an integral, no? So let's start with that. So for each given integral, identify the integrand and the variable of integration. The integrand and the variable of integration. Okay, number one. Let's say we're given the integral of 6 pi dx. So to recall, indefinite integral takes the form of integral of what? Integral of f of x dx, right, guys? So, and this is actually, after evaluation, you will come up with a function denoted by capital F in terms of x, and then added to it some constant, let's say c. Okay, so here, so what is the integrand, guys? What is the integrand, guys? Anyone? Guys?
6 pi x po.
6, again, sorry. 6 pi. 6 pi only, ha? What about the variable of integration? Variable of integration. So this is to be evaluated. So the integral is to be evaluated relative to what variable? Relative to
X po, sir.
x, okay? So the integrand is 6 pi. So everything that is attached to the x, which is inside the integral, is called, integral symbol is called the integrand. So the integrand is 6 pi. So everything that is attached to the x, which is inside the integral, is called, integral symbol is called the integrand. And the variable after the d notation is the variable of integration. So number two, if I have, for instance, if I have integral of e to the 3t, then dt over 4 plus 7 e to the 3t. So what about in this integral? What is the integrand, guys? And also, what is the variable of integration? Who wants to answer that, guys?
Ano po, sir? Yung integral po, e raised to the 3t over 4 plus 7 e raised to the 3t po.
So, the integrand is e raised to 3t all over 4 plus 7 e to the 3t. Is this what you mean,
Yes po.
You know? Okay,
Opo.
thank you. So, very good. What about the variable of integration?
E po.
T. Okay? So, did you get that, guys? Let's just have the last one. So, let's say I have integral of ln of, let's say, w plus 3 times dw over w plus 3. What about this? So what is the variable of integration and also what is the integrand? What about that, guys? Anyone? Guys? Malino? Almadrigo? Reyes? Okay. Charles Dominic?
Sir, ano po?
What is that? You can raise
LNW
your hand,
plus
by the way, if you want to answer. You can raise your hand. Oh, sorry again, Iho.
LNW plus 3
LNW plus 3.
times 1 over W plus 3.
LNW plus 3 all over
W plus 3.
W plus 3. Okay, and what's the variable of integration?
W, sir.
W. Okay, thank you. Is that clear now, guys? So, you know now already the parts of an integral, no? So, you have an integral symbol. Inside, you have a function, and that is called the integrand. And that is to be integrated or evaluating the integral of such relative to what variable? That is the letter or the variable after the D notation. The small d there means differential. Okay? What about guessing the antiderivative? So I am not expecting you to be able to answer this immediately, but you can guess, no? So it's like trying to find out a function that when you get the derivative, it's the integrand. So is that clear, guys? So again, so we are asked to evaluate. So evaluate the given integral by applying so I hope you were able to encounter the general properties of indefinite integrals. There are two kinds of integrals generally, indefinite integrals and definite integrals. The integrals that we are considering so far are indefinite integrals. So the answers to indefinite integrals are functions, no? Collection actually of functions. Integrals or making a wise guess. Or making a wise guess. Okay? So again, a wise guess, ha? Not Bench, not Giordano, ha? Okay, number 1. So let's say we're given integral of differential of t. What do you think the answer to this? Guys, what is that function when I take the derivative? It is equal to let's say 1. But in terms of t, because the variable of integration is t. Then all you have to do, because as a rule, always add an arbitrary constant represented by c, no? We usually use c. Although you can use other letter if you want, or arbitrary constant. Anyone, guys? Guys?
Sir.
What do you think? Huh?
Equals
It is equal to t, no? Or t, because the derivative of t is 1, no? Then plus c. The integrand here is 1, because that is the quantity multiplied to dt, and everything multiplied to dt inside the integral side is the integrand, no? So t plus c, okay? So actually, that is one of the general properties of indefinite integrals, okay? the integral of du is equal to u plus c. So if I have, let's say, integral of 4x to the fifth dx. What about that? What is that function? If I get the derivative, I will get 4x to the fifth. Or, okay, guys? What is that function? Let me change it so that it will be easier. 4x cubed. What is that function? If I get the derivative, I will get 4x cubed.
Ano po, sir? X raised to 4 po.
X raised to 4. And then all we have to do is to add c, no?
Plus po. Yes.
This is just guessing. Later, we are going to have what? Actual formulas, okay? Number 3. What if I have integral of, let's say, 4 cosine 4 theta d theta. What about this? What is that trigonometric function? If I get the derivative, I will get 4 cosine 4 theta. What function is that? Cosine is related to sine function. So sine of 4 theta. Because if I get the derivative, sine 4 theta is cosine 4 theta times the derivative of 4 theta is 4. So we have 4 cosine theta 4 theta. Is that right, guys? Yan.
Yes.
Plus C. Okay? Yan. So let us have the last one. We have number 4, integral of secant squared y, then plus e to the y quantity dy. What about this? Secant squared is related to what function? So what is the trigonometric function? Once I get the derivative, we will get secant squared y dy. Secant squared y. It is tangent, right? Tangent y. And what about for e to the y? So that is e to the y, no? So the function that once I get the derivative, I will get e to the y. That is e to the y also. So hence, the integral of secant squared y plus e to the y quantity dy is tangent y plus e to the y plus c. Okay? So these are so basic, no? So that we can guess, no? The integrals. But there are functions or integrands, so not easy to guess the corresponding function whose derivative is such, no? Or are those, okay? So let's have another exercises. Do as indicated, showing the details of your work. Do as indicated, showing the details of your work. Showing the details of your work. Okay, number 1. So let's say we're given integral of f of x quantity dx, and that is equal to um, 3x squared and then plus 4 e to the y plus c. Okay? So this is the given. So let's say that's the given. So again, if the integral of f of x dx is equal to 3x squared plus 4e to the y plus c, we are asked to find f double prime of 0. What is f double prime of 0? Okay, so that's what we are asked for. The value of the second derivative of f when x is 0. Now, to be able to get the value of the second derivative of f when x is 0, so the first thing to do is to find, of course, your f of x. What is your f of x? Okay? So, and knowing that also, now, right away, there's another condition. So, if let's have this condition. If f of, let's say, 0 is equal to, for instance, 8, no? What is the second derivative when x is 0 of f? Knowing that f of 0 is equal to 8. So let's have this. So again, let us first determine f of x. So given the integral of f of x dx, and that happens to be equal to 3x squared plus e to the sorry, this is supposed to be e to the x, not e to the y. Yeah. So e to the x, no, plus c. Now, to be able to solve for f of x or to determine f of x, so that is in terms of x, so we are going to differentiate what? Its side. Okay? So let's take the derivative of the left side, integral of f of x dx, and then you have to differentiate also the right side. So 3x squared plus e to the x plus c. What's the derivative, guys? What is the derivative? If you differentiate an integral, you will just get f of x, okay? And then on the right side, you will come up with what? Ano magiging right side natin, guys? Huh? I think we don't need pala, sorry. We don't need this condition. We don't need this condition. So that normally happens when it is live. No? I got a mistake with that. So what is the derivative of the right side? So that is 6x plus e to the x, derivative of c, that is constant, 0. Okay? So we know already f of x. But what we are asked, f double prime at 0, no? Or when x is 0. So let's get the first derivative. What is the first derivative of x? We know already f of x. That is 6, na? Plus e to the x. What about the second derivative? The second derivative of x, of f, of x is equal to 0. Derivative of e to the x is e to the x. So we can now find f of f double prime of 0. Therefore, f double prime of 0 is equal to, so we replace x by 0, so e to the 0. And that is equal to what? May 4 pa pala tayo, no? You did not inform me. Guys, di naman yata kayo nakikinig. May 4 pa rito. We're not able to copy it correctly. Guys, tulog yata kayo eh. I will have here 4. Guys, 4 e to the x plus c. Then, derivative is 4 of 4e to the x is 4e to the x. So, first derivative ay integral nito, no? So, ay derivative nga, sorry. Differentiate natin. O, ang derivative naman ng f, because we want to get the second derivative, 6 plus 4 e to the x. And what about the derivative of this? To come up with the second derivative, that is 4e to the x. Okay now? So our answer is 4e to the 0 for f double prime of 0. So that is now equal to 4. Okay? Is that clear, guys? So the
Yes,
answer is 4. Let's have another one. Let's say we're given number 2. If f of x is integral of capital F of x dx is equal to if and that is equal to tangent of x squared plus ln of x squared plus 1 plus c, find plus c, find f of x squared. So what we are looking for is capital F of x squared. Okay? So again, first we have to find capital F of x. So how to find or how to determine capital F of x? So given the integral of capital F of x, quantity dx, plus that is equal to tangent of x squared plus ln of x squared plus 1 plus c. Okay, guys? So, by the way, another way to do it, from the definition of antiderivative, our capital F ito. Kaya lang, ang binigay na integral is also capital F. That is small f yan, no? Kaya ito ngayon yung ating pinaka-capital F. So, how is capital F related here? Kaya lang dahil confusing because capital F naman ang ginamit sa loob. Okay? So, gamitin natin yung relationship nila. Dapat, pag nilet ko, let's say ng, let's say, G. Yan. Small f na lang. Small f of x. Yung tangent x squared plus ln of x squared plus 1. So, ano ang relationship ng small f sa capital F dito? Kapag dinifferentiate ko raw yung capital F, I mean yung small f, dapat ang lalabas yung capital F. Dati, kapag dinifferentiate ko yung capital F, ang lalabas small f. Kaya lang kasi baliktad yung position nito, no? Ang nasa loob, capital F, kaya ito ngayon ang small f natin. So, ang derivative ng small f dapat should be the integrand. Okay? So, let's do that. So, we now have, what's the derivative of capital, of small f? So, that is equal to what? So, you will now able to get f of x. Anong derivative? So, that is secant squared of x squared. But what is the derivative of x squared? That is 2x. Then plus, what about ln of x squared plus 1? The derivative of this is equal to derivative of the inside, that is 2x, over x squared plus 1. Okay? So, we can now find capital F of x squared. Just replace everything that is everything that is x in the f of x by x squared. So that is your capital F of x squared. So let's do that. So therefore, f of x squared is equal to 2 times, what is x? X squared. So secant squared of x squared. So it will become x to the fourth. Okay? Then plus ln of 2x. So, I'm sorry, 2x. But what is x? X squared. All over x squared. So when we square the x squared, that is x to the fourth. Plus 1. Okay, guys? So that is capital F of x, the function that we are looking for. Any question, guys? Guys? Let's have number 3. If f of x is equal to, let's say, if the integral of f of x dx is equal to 1/4 x to the fourth minus x cubed plus c, find the relative or local. It is also called local, relative or local. Or local. Relative or local extreme point. Extreme points of f. Do you still remember relative or local extreme points of a function? Guys? Guys, do you still remember your differential calculus? What do you mean by relative extreme or local extreme points? These are relative minimum or relative maximum points, okay? How do we get them, guys? How do we get relative extreme points or relative x values that will give relative minimum, relative maximum? We get to what? Huh? We get to what? Manuel Jordan?
And
Yes?
second derivative test.
So we are going to get first the critical numbers. And then after that, so of course, and to get the critical numbers, you're going to test it using the first derivative or second derivative test, no? So after getting the function f, okay? Let's do that. And so you do not have to forget your calculus differential. So how to get f of x? So we know that we are given integral of f of x dx, and that is equal to 1/4 x to the fourth minus x cubed plus c. So we can get the derivative of each side. So getting the derivative of each side to get rid of the integral sign. So this is equal to the derivative of the right side relative to x. So integral of derivative of 1/4 x to the fourth minus 3 minus x cubed, then plus c, no? So the derivative of the integral of f of x dx is simply f of x because they are opposite what? Operations, no? So, and that is equal to, what about the derivative of the first term? 4 times 1/4. So then times x, 4 minus 1, so 3. So getting x cubed. What about the second term? 3x squared. Derivative of z, 0, no? Okay? Then from here, after getting the function now, get the first derivative. So getting the first derivative, we have 3x squared minus what? 6x. Is that right? Now, to get critical numbers, for critical numbers, we have to equate what? F prime to 0. For critical numbers, we are going to equate f prime to 0. So f prime of x is equal to 0. So it means 3x squared minus 6x is equal to 0. So factoring out 3, we have then together with the x. So we have x squared minus what? Is it minus 2? Guys,
Sir, X lang po.
mali ba ako?
X lang po. Hindi po X squared.
Which one? Mali ako?
Yung nasa
3x
baba ng parenthesis.
minus 2.
So, saan ako nagkamali?
X minus 2 lang po dapat.
X minus
2 lang po.
X minus 2. Ay, sorry. Oo nga. X minus 2. Oh, sorry. X minus 2 equal to 0. Okay now, guys? And then after that, we equate each factor to 0. So, x equals 0, x equals 2. So, these are the critical numbers. Okay? Now, which among these critical numbers is the relative minimum, relative maximum? So, that's what we mean by extreme points. Which of these two numbers will give the relative minimum point, relative maximum point? So, let us use second derivative test. By second derivative test, getting the second derivative. What is the second derivative, guys, of the function f? Guys, what's the second derivative?
6x minus 6.
6x minus
So we
6.
have 6x minus 6, no? So at x equals 0, so we get the value of the second derivative. So 6 times 0 minus 6. So and that is negative 6. So this implies that x equals 0 gives relative maximum point na. Because the second derivative is less than 0. Okay? So, but by the way, what is the corresponding value ng y? When x is 0, what is y in the function? That is f of 0. 0 minus 3, 0 cubed minus 3 times 0 squared. So that is 0. So we have 0, 0 is what? Is a relative minimum point. Ay, sorry. Relative maximum point. Am I right, guys?
Yes po.
Yes,
If
po.
second derivative is negative, so we get a relative maximum point. So at the point where x equals 0, I mean x equals 2, anong kapartner kapag ang x ay 2? Let's go back to the function. 2 cubed, what is that? 8, right? Guys?
Apo.
Minus 3 times 4 because 2 is squared. So the partner is negative 4. So we have the point 2, negative 4. What's the value of the second derivative when x is 2? That is positive 6. Na? Greater than 0. So it means the point 2, negative 4 is a relative or local, no? Local minimum point. Relative minimum point. Okay, guys? Do you have any question with the problem? Guys? Yan. So these are some exercises. So applying antiderivative. Okay? As long as you understood antiderivative, you will be able to solve problems involving such. Of course, you do not have to forget the principles that you learned in your differential calculus. Let's now move to exercises on general power formula. together with simple power formula, of course. So again, I hope you have watched the videos regarding this. So we have general power formula. So this is letter B. Exercises on general power formula for integration. For integration. Those who have just enrolled and you missed announcements about the videos that I asked you to watch, could you please go over with them, huh? So general power formula takes the following form. So you will have the integral of u to the n du is equal to what? U to the n plus 1 all over n plus 1. Okay? We are here. So what are the condition, guys? Where u is what? Where u is a function of x, and we assume that is differentiable. And then, n here not equal to -1. N can be any real constant as long as not equal to -1. Is that okay, guys? And of course, du is the derivative of f multiplied by dx. So this is then, don't forget to add c. Yeah. Plus c every time you evaluate the integral. So let's have number 1. So evaluate the given integral and evaluate the following. Evaluate the given integral. So we mean this indefinite integral. Number 1. By the way, this is a PowerPoint. I am using a PowerPoint as a Blackboard. I just changed it to green background and I put an image at the top and bottom. So I got it from an actual Blackboard, that picture. So number 1, we have integral of dx over fifth root of x. So how are we going to evaluate this? Give me an idea, guys. Guys, give me an idea on how to evaluate this. So what is the first thing to do, guys?
Sir, going fractional po. Fractional exponent. Going fractional exponent po.
And then bring it up, no?
Yes.
So it means x to the 1/5. When you bring it up, it becomes what? It becomes x to the negative 1/5. Is that right? So that is equal to integral of x to the negative 1/5. And this now becomes simple power formula, no? You can apply simple power formula here. This fits that. So, and this is equal to, what is the integral of x to the negative 1/5 dx? So, our x, so x, then u to the n plus 1. I mean, n. So, ito yung pinakayo natin, no? U to the n plus 1. What is n here? N is negative 1/5. Oh, and that is not equal to -1. So, we proceed. So, when you add 1, it becomes 4 over 5. The exponent, no? Over 4 over 5 plus c. Simplifying, this is equal to 5 over 4, then multiply to x to the 4 over 5 plus c. Okay, guys? Yan. Okay, number 2. What if I have integral of y to the 4th plus y quantity to the 7? Ay, sorry. Quantity squared dy. What about that? Any suggestion, guys, of what to do here? Guys, based on the video that you watched, guys, what is our u here? Can we have an immediate u here? Can we take y to the 4th plus y as our u in this case? Guys,
Yes, sir.
Yes po.
if we take y to the 4th plus y as our u, what is the differential of that? Let's say I take u to be y to the 4th plus y with n equals 2. What about the du? What's the du? For y cubed plus 1 quantity dy. But unfortunately, remember, after taking u, you must be able to come up with the du. So the remaining must be du. But the remaining here is just dy. So very far from the du. So again, if this is u and 2 is n, u to the n, but this dy happens to be not du. So substitution like this is not what? Will not give you progress, no? It's not that it is wrong, but it will not give you what you want, no? What you really want. Okay? So we think of other way. So this is what? Not possible. So not possible. Okay? So what is the other suggestion, guys? Any other suggestion? Huh? We need to what? Because this does not work, you are going to expand. Let's try to expand so that we can apply integration term by term, applying simple power formula. Okay? So getting y to the 8th plus 2y to the 4th times y. So you will get y to the 5th. Am I right? Y to the 5th. Then y squared. Okay? Yan. Quantity dx. So from here, we can apply term by term integration. You can do it by what? By inspection, no? U to the n or y to the n dy. So this is supposed to be dy. I love x. That's why I always write x. What is y to the 8 dy? Simple power. Y to the 9 over 9, no? What about the second term? What is the integral? 2 times y to the 5th dy. So that is y to the 6 over 6. And the last one, integral of y squared dy, it gives us y cubed over 3. Then plus the constant of integration. One constant of integration is enough. Even we did 3 integrations independently. Okay? Yeah. Because if you have C1 for the first one, C2 for the second one, and C3 for the third one, we can combine all of them into a single arbitrary, which we call, let's say, C. No? Yeah, that's it. Or that is 1 over 9, y plus 1/3, y to the 6 plus 1/3 y cubed. Is there any question here, guys? Guys?
None po.
Huh?
None so far.
What about number 3? Number 3, let's say we're given integral of 1 plus 1 over x raised to 2 over x raised to 7 all over x squared quantity dx. What about this? So since the exponent is 7, of 1 plus 2 over x, it is not practical to expand, no? So let's try finding u and then determine if the remaining expression inside, together with the dx, is our du. Is that okay, guys? Guys,
Yes.
I ran out of board. Perhaps my
Yes, sir.
no, don't have any more board. So wait a minute. Okay. X B. Ay, sorry. I have to transfer. Transfer ko ito diyan sa unahan. Okay. Let's copy the problem. Ay. Copy. Let's move to the next slide. So we have solution. So let's see if general power formula will work here. It's not always the case that it is general power, ha? Later, if you have so many formulas, you have to learn how to identify the appropriate formula to be applied to be able to evaluate the given integral. Okay? What is our u here? Let's try. Anong possible u, guys? Guys, anong possible u? What do you think? So, the wise choice of u is, of course, 1 plus 2 over x na. What is the derivative of 1? 0. No? What about the derivative of 2 over x? What's the derivative of 2 over x? Negative 2 over x squared. Then dx. Okay? So notice that it's almost du, the remaining, no? If I take this as u, 1 plus 2 over x, u, and then 7 is the n, u to the n, the remaining is almost du. So we are just what? We are just missing the negative 2, no? So what do you want? U-substitution or direct? Indirect na lang, ha? So I'm going to rewrite the given integral, okay? So we now have integral of u. This is my u. Yan. Then this is my n, and the remaining is supposed to be part of the du, and that is dx over x squared. Again, this is not yet du. We have to complete it. So to complete the du, we have to multiply this by negative 2, right? Okay? Then, but don't forget to balance outside by negative 1/2. So let's rewrite now the integral. This is equal to integral of 1 plus 2 over x raised to 7 times negative, I am going to put negative 2, then copy the remaining x squared dx. Yan. So this is what I supplied. So again, what did I supply, children? I supplied negative 2. So I have to balance outside by negative 1/2. So that mathematically, I did not really change the given. No? The value will still be the same with the original. So let's now read if this is already satisfying the general power formula. So negative 1/2. Copy that. Let's read integral of u to the n du. So again, what is this, guys? This is n. What about this, guys? This is u. And this thing is what? Du. So it's already in the proper form, no? Integral of u to the n du. Since the sound is already integral of u to the n du, I can now answer. If the sound is already correct, Then what is the answer to the correct sum? Integral of u to the n du. The correct answer is u to the n plus 1. U to the n plus 1 all over n plus 1. But what is our n? I mean u. 1 plus 2 over x. U to the n plus 1. So it is now 8 all over n plus 1. So that is 8 plus c. Okay? So, and that is equal to negative 1 over 16 multiplied by 1 plus 2 over x quantity to the 8. O c plus c. Very easy. Okay, guys? I think mas mahirap pa those that are in the video, no? Let's have number, what number are we now? 3, so this is 4. Let's have number 4. Yeah. What about this one? Integral of ln of x squared. You watch the video, there are so many examples that I prepared in the video. Because we will not able to discuss everything, no? Yeah. That's why very important if you have such, no, you can watch it everywhere you are, anywhere you are, I mean. No? X squared minus 4, quantity dx times x here. Okay, let me... Ayaw, ito na lang. Undo. So this is x here. Yan. What about this? An idea? Could you give me an idea on how to attack this kind of problem, guys? Huh? What are you going to do, guys? Guys? Any suggestion, guys? So what is our u here, guys? What do you think? What is our u?
X squared minus 4.
If u is x squared minus 4, what happens to ln? Can we get ln out of x squared minus 4? I don't think so. So I think we need to include the ln, no? Because experience, the derivative of ln is algebraic in form, no? So x squared minus 4. Okay, guys? What about our n? Ang n natin is equal to what? 1, no? What about the differential of u? What's the derivative of ln? Derivative of x squared minus 4. That is 2x over what? Over x squared minus 4, no? The u of that ln is x squared minus 4. Then multiplied by dx because what we are getting is differential of u. Is that clear, guys? Do not forget the dx, ha? So let's now rewrite the given integral. The given integral can be rewritten in the form of u, ito yung u natin, then x squared minus 4, and then the potential du, x dx, all over x squared minus 4, the remaining quantity inside, okay? Now, let's fix the differential of u. So this is supposed to be the du, but unfortunately, it's not. So what is missing for this to be du, guys? Anong missing, guys?
2, sir.
2. Then we balance outside by 1/2, no? Yan. Times, we multiply by 2. So let's put 2 there. Then we copy the original quantities that are in the integral, no? X or dx over x squared minus 4. Okay, so we now fix the du, but of course you don't have to forget the 1/2 outside. Okay, guys? Yan. So that
Sir,
compensated. Okay, yung x pala missing pa. I haven't write the x. So there are still missing. Ano pa yung nawawala ko? So originally, x is present. No? Yan. Okay now, guys? Oh. So let's now read. So this is 1/2, copy. Integral of u. That is our u. This is our u, the ln. What is our n? Our n is supposed to be here, which is 1. The whole exponent of ln. And this is our what? Our du. Is that correct, children?
Yes, sir.
What
Yes.
is supposed to be the answer? Huh? What is supposed to be the answer, guys? 1/2 what? So if the sound is u, integral of u to the n du, what is supposed to be the answer? U to the n plus 1, but our u is ln, no? U to the n plus 1, so ln squared now, of x squared minus 4, all over
2.
2, and then plus your favorite as Catriona Gray, no? And finally, we have 1/4 ln squared of x squared minus 4 plus c. Okay, guys? So it's very easy. Last one for this, so that we can talk about what? The logarithmic formula. Okay? Yeah. So let's have a little bit challenging. So let's say we're given the integral number 5, 6. Is it 6, guys? 4, 5. Number 5. We have integral of 2. I do not know if this is in the video. 2x tangent inverse tangent of x, then plus ln of x squared plus 1. Yan. Quantity all over x squared plus 1 raised to 1 minus tangent inverse of x, or inverse tangent of x. -1 in the tangent does not mean exponent, ha? It means arctangent. Then dx. Okay? Look at the problem, guys. Try to analyze it. Any suggestion, children? Guys, any suggestion of what to do? Because arctangent and ln not directly related, no? So this problem suggests that we need splitting. So it will give us 2 independent integrals. Okay? But ln and tangent inverse have something in common. If you take the derivative of arctangent of x, it will have a denominator that is looking like x squared plus 1. What about the ln? If you take the derivative of ln of x squared plus 1, you will have also a denominator looking like x squared plus 1. Did you get my point, children?
Yes po.
Yeah.
Yes.
So we need splitting, na? And how to
Yes, sir.
split? That's the challenging there. Okay? Yeah. How to split? So let's have. So to be able to split that, first we must be able to segregate or get x squared plus 1 away from 1 minus tangent inverse of x. Okay, how to do that? We apply one of the laws of what? of exponents na. Okay, guys? O, let me rewrite it here. So, this quantity, guys, I will have a separate for that. Yan. So, x squared plus 1, guys, can I have it, let's have it here. I'm thinking of writing on the other side. Yan, minus tangent, inverse tangent of x, that is equal to what, children? Equal yan saan, guys? Guys, ha, sa 1, guys, sa x squared, you can split that, right? X into factors. X squared plus 1 raised to 1 times x squared plus 1 raised to what, guys? Raised to
Negative
negative
arctangent.
tangent inverse of what? Of x. Am I correct?
Yes po.
Yan. And then after that, what comes next? So the integral, yan, this integral, I have to split that now. So let's split into integral of what? Into 2x tangent, inverse tangent of x over, yan, o then dx over this thing. Ito yung common denominator nila, right? Guys?
Yes po. X
So we now have x squared plus 1, then raised to negative tangent inverse of x. Yan. Then, yan. And what time is it? Already 1:19. If we don't have much time, I'm going to make it an assignment, ha? I will start with it and then you will be continuing. Oh, then next, what is the second? I think I missed the other one. Dapat ito ay dapat may 1 pa muna. Yan. Kasi kailangan ko yung isa, naka-split yung isa naman. Dapat ito, may 1 pa rin siya, no? So the whole thing may times what? X squared plus 1, yan, raised to negative tangent. Wala pa naman ako nakakancel. Yan. So let's see yan, if this will work. Gitna-gitna lang natin yung numerator. Ungroup. Let me get the numerator. Yan. And then the second integral, and plus integral of ln over. Yan. We have x plus 1 times what? X squared plus 1 times what, guys? Times x squared plus 1 raised to what, guys?
negative
Ayan.
arctangent.
Tingnan natin kung ano nang itsura niya. Okay? Ayan. Then this is ln of x squared plus 1. Okay? Yan. What comes next? Ano na sa tingin nyo, guys? May kulang ako. May 5 dito. May 5. Nasa na ba yung 5? Bakit ganon? Kulang pala ako sa given ng 5. Diba yan? Labo na ng mata ng teacher. May 5 dito dapat. 5. So dito may 5. May 5. Mayroon ditong 5. Lahat may 5 yun, ha? Yan, may 5 yun. Hindi siya masyadong kita sa last. Five tangent inverse of x. What about that? What do you think the next step to do? Guys, alin ang u dyan? O baka naman hindi pala dapat split. You know, integration is trial and error. If your first try will not work, then try to find another algebraic technique so that you will come up with u to the NDU or any desired formula. What do you think, guys? Huh? Guys. Guys.
Yung 2x arctan po.
Ha? Ano ang u natin?
2x arctan.
Pag 2x arctan, yan, ang u natin, let's say u equals x times 2 arctan x, ang du niya is what? Ang du is, let's have a scratch here. The first derivative of the second plus the second derivative of the first times 2. Will it have a then multiplied by everything by dx? Does it something to do with the remaining quantity? It's not, I think. Ano sa tingin niyo? Guys.
Baka po yung ln po. ln
Yung
plus 1.
an ln then I think. So, I will give a hint. I think ang you try ha, kasi it's almost time. We will be answering this next meeting. But let me first, let you first try, no? So, ang you I think is, you are going to split it in this, and then you bring this up. You bring this up. Do not split the integral. So you bring that up. So it means I will get an integral something integral. Then I'm going to bring up x squared plus 1 raised to 5 arctan inverse of x. And then the remaining is what? Yung, di ba, there is a remaining x squared plus 1 in the denominator that I did not bring it up, this part. And then the original denominator, this 2x tan inverse x plus something ln what? X squared plus 1 quantity dx. And this will serve as our perhaps u. Okay? But our u is something x squared plus 1 raised to 5. Or you can get rid of the 5, just tangent, inverse, and for the meantime, take n equals 5. But later, sometimes, you need to give a part of this to this so that what? So that you will come up with the differential, no? Yeah. So, at how do we differentiate if you have a function like this? Function raised to a function. Ang gagawin nyo, you have to take the ln. ln of u equals ln of this. Ang ln of this is what? Yan. The exponent of this x squared plus 1 will become what? Will become coefficient. So you will get inverse tan of x times ln of x squared plus 1. So that if you what? If you are going to differentiate this, the first, ito yan, the first, ito yan, arctan x. Derivative of the second, 2x. 2x, ayan, may 2x ka. 2x all over x squared plus 1. Diba, may x squared plus 1 ka? Plus the second, ito yung second. O, diba, meron kang ln x squared plus 1 here, times the derivative of the first. E, ano ba ang derivative nito? Diba yung x squared plus 1? O, do you get that, guys? O, I'm giving you the hint, ha? So, that's what you're going to do. Okay, guys? Ayan, ha? You are going to post the solution in our FB group. So, ang first 10 who will able to get the correct answers, scan nyo and paste there sa FB. I will put a discussion there where you can comment your solution. So you will be given additional points. Okay? So it means splitting is not a nice way, you know? It's not that it is wrong, but it will not give you progress. Is that clear, guys? Hi, guys.
Yes po.
Yes po.
Yan.
Yes po, sir.
So this is a better way, I think. No? Yan. Even kami teachers, no? We try and try. We don't know, we can't anticipate what will really happen along the way. So after trying to manipulate, that's the time we will see how we can do it, no? So even kami, no? It's a trial and error. Especially if you have a problem like this, which is not an ordinary problem. Okay, guys? Okay. If you do not have questions anymore, then you can leave. Don't forget, ha, guys? This is your problem, ha? So you're going to post in our FB group. So that problem, ha? So anong problem? I will make it larger. Integral of... yan. Dapat, I think, it's not that, no? Ganito dapat. Para talagang looking like difficult problem, no? Yan. Yan, ha? Parang hindi maganda. Ay, sorry. Yan, parang hindi maganda yung ahas ko. So, yan. Para siyang ahas. Yan, yan. Okay? Yan, yan. Kaya, it's really difficult. If you're given a problem like this, with that symbol, it means challenging. 2x, tangent, inverse tangent or arctan of x, then arctan of x, then plus ln of x squared plus 1 all over. Yeah. So see, it's already time. Yan, dx, then x squared plus 1 quantity square, 1 minus tangent, 5, no? 5 tangent inverse of x. Yan. O, see? Although very nice the problem. Oh, it's like a snake. So it means it is really challenging. No? Pag bulati lang, mga simple. Yan. Okay? O, take a picture of that. So I'm going to post this also in our FB group. Okay? Snip ko siya. Yan. Yan. Para you will just comment there. And any question, guys? Okay. Thank you. Don't forget to type your name for your attendance, ha, guys.
Yes po, sir.
Yan.
Thank you, sir.
I-record ko lang
Thank you
itong
po.
Thank you
attendance.
po.
Thank you po, sir.
Thank you po,
Kasi
sir.
mawala.
Thank you, sir.
Thank you po, sir.
Okay.